So hello friends, welcome to my channel. So in this video I am going to explain you about the Kcet 2025, the physics question paper answer key 16th April 2025. So the question paper, its code is T4. So the first question is, a wooden block of mass m lies on a rough floor. Another wooden block of the same mass is hanging from the point O through strings as shown in the figure. To achieve equilibrium, the coefficient of static friction between the block on the floor with the floor itself is mu is equal to cot theta, mu is equal to sin theta, mu is equal to tan theta, mu is equal to cos theta. So T sin theta is equal to mg. Cos theta is equal to mu mg, so therefore mu is equal to cos theta by sin theta, that is equal to cot theta. So therefore the answer is option 1. Next, the second question is, a block of certain mass is placed on a rough floor. So the coefficient of static and kinetic friction between the block and the floor are 0.4 and 0.25 respectively. A constant horizontal force F is equal to 20 N acts on it so that the velocity of the block varies with the time according to the following graph. The mass of the block is nearly, they have given. Okay, so the friction must be kinetic, so therefore A is equal to V minus U by T, so therefore it is equal to 20 minus 0 by 3, therefore it is equal to 20 by 3, so therefore F minus Fk is equal to Ma, so therefore 20 minus 0.25 meter into 10 is equal to M into 20 by 3, so therefore it is equal to 2.2 kg, so therefore the answer is option D, 2.24 kg. So the next question is question number 3. Here, a body of mass 0.25 kg travels along a straight line from x is equal to 0 and to x is equal to 2 meter with a speed of v is equal to k in x 3 by 2, where k is equal to 2 SI unit. The work done by the net during this displacement is 8 joules, 16 joules, 32 joules or 4 joules. So the formula is W net is equal to KE. So therefore 1 by 2 mv square minus 1 by 2 mu square. So therefore 1 by 2 into 0.25 k into 2 3 by 2 into the power 2 minus 0. So therefore it is equal to 1 by 2 into 0.25 into 2 square into 2 cube. So therefore it is 4 joule is the answer. So therefore the correct answer is option D, 4 joule. Next, fourth question. During an elastic collision between two bodies, which of the following statement are correct? The initial kinetic energy is equal to the final kinetic energy of the system. The linear momentum is conserved. The kinetic energy during the collision time is not conserved. So the options is second and third only, first and third only, first, second and third, first and second only. So the first one, the final total kinetic energy equals initial, and the linear momentum is always conserved. And the third point, that is during collision, kinetic energy gets partly converted to potential energy. So all these statements are correct. So therefore the correct answer is option C. Then question number 5. Three particles of mass 1 kg, 2 kg and 3 kg are placed the vertical A, B, C respectively of an equilateral triangle ABC of side 1 meter. The center of mass of the system from vertices A is first one, first option 7 by 12 comma 3 to the root 3 by 12, 9 by 12 comma 3 to 3 root 3 by 12, 7 by 12 comma 6 plus 3 root 3 by 12. Fourth option is 0 comma 0. So this is the solution where the formula x is sigma mixi by sigma mi. So 1 into 0 plus 2 into 1 plus 3 into 1 by 2 by 6. So therefore it is equal to 7 by 12. So therefore y centimeter is equal to sigma mi yi by sigma mi. So therefore it is equal to 1 into 0 plus 2 into 0 plus 3 into root 3 by 2 by 6. So therefore it is equal to 3 by 3 into root 3 by 12. So therefore the correct answer is option 1. Next, the question they asked is two flywheels are two flywheels are connected by a non-slipping belt as shown in the figure. I1 is equal to 4 kilogram, R1 is equal to 20 centimeter, I2 is equal to 20 kilogram square, and R2 is equal to 30 and I2 is equal to 20 kilogram. So a torque of 10 Nm is applied on the smaller wheel. Then match the entire entries of column 1 with appropriate entries of column 2. So first one, that is quantities, and second one is their numerical values. Angular acceleration of smaller wheel 5 by 3 and torque on the larger wheel 100 by 3, and angular acceleration of larger wheel is 5 by 2. So the option C is A is equal to 2, B is equal to 3 and C is equal to 1. Option 2 is A is equal to 3, B is equal to 1, 2, C is equal to 2. Option 3 is equal to A is equal to 2, B is equal to 1, C is equal to 3. Option 4 is equal to A is equal to 3, B is equal to 2, C is equal to 1. So the formula is T1 is equal to I1AI. So therefore 10 is equal to AI into 4. So therefore it is equal to 5 by 2 SI. So therefore the answer is option D. A is equal to 3, B is equal to 2, C is equal to 1. If RP, VP, LP and RA, VA, LA are radii, velocities and angular momenta of a planet at perihelion and aphelion of its elliptical orbit around the sun respectively, then RP is greater than RA, VP is greater than VA, LA is greater than LP, or RP is greater than RA, VP is greater, RP is smaller than RA, VP is greater than VA, LA is equal to LP, RP is greater than RA, VP is smaller than VA, LA is equal to LP, RP is smaller than RA, VP is smaller than VA, LA is smaller than LP. So therefore the solution is angular momentum is conserved, so therefore LP is equal to LA. Perihelion is point closest to the sun, so therefore RP is less than RA. Also MVP RP is equal to MVA RA, so therefore VP is greater than VA. So therefore the correct answer is option 2. So the total energy of a satellite in a circular orbit at a distance r plus h from the center of the earth varies as. So therefore the options again 1 by r plus h, 1 by r plus h whole square, 1 by r plus h whole square minus 1 by r plus h whole square, plus 1 by r plus h. So therefore the formula is g m by m into m by 2 r plus h. So therefore the answer is 1 by r plus h. So therefore the option is correct for first one. So two wires A and B are made of same material. Their diameters are in the ratio of 1 is to 2 and length are in the ratio of 1 is to 3. If they are stretched by the same force, then increase in the length will be in the ratio of 3 is to 4, 2 is to 3, 3 is to 2, 4 is to 3. So this is the formula. So by using this formula, 1 by 3 into 2 by 1 whole square is equal to 4 by 3 we have got. So therefore it can be 4 is to 3. So therefore the correct option is option D. Next, a horizontal pipe carries water in a streamlined flow at a point along the pipe where the cross-sectional area is 10 centimeter square. So the velocity of water is 1 meter per second. So and the pressure is 2000 PA. What is the pressure of water at another point where the cross-section area is 5 centimeter square? First one is 300 PA, second option is 400 PA, third option is 500 PA, fourth option is 200 PA. So therefore the formula is A2 V2 is equal to A1 V1 and V2 is equal to A1 V1 by A2. So therefore it is equal to 10 into 1 by 5, that is equal to 2 meter per second, and 1 by 2 P2 plus 1 by 2 PV2 square is equal to P1 plus 1 by 2 PV square P1 square. So therefore P2 is equal to 2000 plus 1 by 2 into 1000 into 1 square minus 2 square, that is equal to 500 PA. So therefore the correct option is option C. Then the three metal rods of the same material and identical in all respects are joined as shown in the figure. So the temperatures at the end of these rods are maintained as indicated. Assuming no heat energy loss occurs through the curved surfaces of the rod, the temperature at the junction X is 60 degrees Celsius, 30 degrees Celsius, 20 degrees Celsius, and 45 degrees Celsius. So T is equal to H1 plus H2. So Tx minus 0 by R is equal to 90 minus Tx by R plus 90 minus Tx by R. So therefore 3Tx is equal to 180. So therefore Tx is equal to 60 degrees Celsius. Next, 12th question is, a gas is taken from state A to B along two different paths 1 and 2. So the heat absorbed and work done by the system along these two paths are Q1 and Q2 and W1 and W2 respectively. Then W1 is equal to W2, Q1 minus W1 is equal to Q2 minus W2, Q1 plus W1 plus Q2 plus W2, and Q1 plus Q2. Q1 is equal to Q2. So therefore, U is equal to Q minus W. So the U1 is equal to U2. So therefore, Q1 minus W1 is equal to Q2 minus W2. So therefore, the correct option is option 2. Okay. Option B is the correct answer. Then 13th question. At 27 degrees Celsius temperature, the mean kinetic energy of the atoms of an ideal gas is E1. If the temperature is increased to 327 degrees Celsius, then the mean kinetic energy of the atoms will be E1 by root 2 E1, 2 E1, E1 by 2. So therefore, Ke mean T. So E1 by E2 is equal to T1 by T2. So therefore E2 is equal to E1 into T2 by T1. So therefore E1 is equal to 327 plus 273 by 27 plus 273. So therefore 600 by 300. So therefore it is equal to 2E1. So therefore the correct option is option 3. Next 14th question, the variation of kinetic energy Kx and potential energy Ux and the total energy as a function of displacement of particle in SHM is as shown in the figure. So the value of x0 mod is 2a by root 2 root 2a by 2. At x0, Ke is equal to Pe 1 by 2 mw square a2 minus x2 is equal to 1 by 2 mw2 x2. So therefore 2x square is equal to a square. So therefore x is equal to a by root 2. So therefore x is equal to a by root 2. So therefore the correct option is option 2. Next, the 15th question, the angle between particle velocity and wave velocity in a transverse wave is pi by 4 radian, pi by 2 radian, pi radian, 0 radian. So in the transverse wave, particle oscillates perpendicular to direction of propagation of wave. So therefore, hence the angle is pi by 2 radian. So therefore, the correct option is option 2. In 16th question, a metallic sphere of radius r carrying a charge q is kept at certain distance from another metallic sphere of radius r by 4 carrying a charge q. What is the electric flux at any point inside the metallic sphere of radius r due to the sphere of radius r by 4? So therefore the formula is q by e naught is a minus q by e naught, 0, q small q by e naught minus large q by e naught, q small large q by e naught. So since pair is electrostatic shield from each other, so Q naught is equal to 0. So therefore the answer is option 2, that is 0. In the 17th question, you are given a dipole of charge positive and negative q, separated by a distance 2r. A sphere A of radius r passes through the center of the dipole as shown below, and another sphere B of radius 2r passes through the charge plus q. Then the electric flux through the sphere A is q by E naught 0, 2q by E naught minus q by E naught. So sphere A is equal to charge enclosed by E naught by gas law. So therefore it is equal to minus q by E naught. 18th question is, a potential at a point A is minus 3 volt, and that or another point B is 5 volt. What is the work done in carrying a charge of 5 meter C from B to A? That is first option is 0.04 joule minus 0.04 joule, 0 minus 0.4 joule, 4 joule minus 4 joule, and minus 40 joule. So W x is equal to Q or V. So therefore Q Vf minus Vi. So therefore 5 into 10 to the power minus 3 Va minus Vb. So therefore 5 into 10 to the power minus 3. So minus 3 by minus 5. So therefore it is equal to minus 8 into 5 into 10 to the power minus 3 joule. So therefore it is equal to minus 40 into 10 to the power minus 3 joule. So therefore it is equal to minus 0.04 joule. So therefore the correct answer is option 1, that is minus 0.04 joule. So next 19th question. Charges are uniformly spread on the surface of a conducting sphere. So the electric field from the center of the sphere to a point outside the sphere varies with distance r from the center as. So for conducting sphere, E is equal to 0 for r less than r. So E is equal to kq by r square for r small r greater than or equal to r. So it will be the first one, first graph is the answer, option 1. So next 20th question. Match column 1, column 2 related to an electric dipole of dipole moment P that is placed in a uniform electric field E. Column 1, angle between P and D. Potential energy of the dipole 180 degree, 120 degree and 90 degree minus PE 1 by 2 PE 0. So the first option is A is to 1, B is to 2, C is to 3. A is to, second option is A is to 2, B is to 3, C is to 1. Third option is A is to 2, B is to 1, C is to 4. Fourth option is A is to 2, B is to 3, C is to 4. P of dipole is equal to P is to E in minus is equal to P E cos theta. So first one, theta is equal to 180 degree, P is equal to minus PE cos 180 degree PE. So therefore theta is equal to 120 degree, PE is equal to minus PE cos 120 degree, that is equal to minus PE minus 1 by 2. That is option 3. And theta is equal to 90 degree, P is equal to minus PE cos 90 degree is equal to 0. So therefore it is option 4. So therefore the correct answer is option 4. A is equal to 2, B is equal to 3 and C is equal to 4. Next, in 21st question, which of the following statement is not true? First one is, work done to move a charge on an equipotential surface is not zero. Equipotential surface or the surface where the potential is constant. Equipotential surface for a uniform electric field are parallel and equidistant from each other. Electric field is always perpendicular to an equipotential surface. So the correct one is first option, that is work done to move a charge on an equipotential surface is not zero. Because equipotential surface is having same potential at every point, so work done in moving a charge from one point to other is 0. Then, which of the following is a correct statement? Gauss law is true for any open surface. Gauss law is not applicable when charges are not systematically distributed over a closed surface. Gauss law does not hold good for a charge situated outside the Gaussian surface. Gauss law is true for any closed surface. So Gauss law is valid only for closed surface, and charge should be enclosed inside the closed surface to get flux through the closed surface. So therefore the correct answer is option 4. Next, in the following circuit, the terminal voltage across the cell is 1.68 volt, 1.95 volt, 2.71 volt, 0.52 volt. So therefore first option is first I is equal to 2 by 4 is equal to I by 1 by 2a. So therefore terminal voltage is equal to 2 minus 1 by 2 into 0.1. So therefore it is equal to 1.95 volt. So therefore the correct option is option 2. Next question, two cells of EMF E1, E2 and internal resistance R1 and R2 respectively are connected in parallel as shown in the figure. So the equivalent EMF of an combination is EEQ. So therefore first option E1 is less than EEQ, less than E2, and EEQ is nearest to E2. EEQ is greater than E2, EEQ is lesser than E1, E1 is lesser than EEQ, lesser than E2, and EEQ is nearer to E1. So therefore E1 plus E2, EEQ is equal to R1 into R2 by 1 into 1. So therefore it is equal to E1 R2 plus E2 R1 by R1 plus R2. So therefore it is equal to E1 and E2. So therefore the correct answer is option 4. 25th, the variation of resistivity with the absolute temperature T for three different material X, Y and Z are shown in the graph below. Identify the material X, Y and Z. X copper, Y semiconductor, Z nichrome. X semiconductor, Y nichrome, Z copper. X nichrome, Y copper, Z semiconductor. X copper, Y nichrome, Z semiconductor. So X is a copper, Y is nichrome and Z is semiconductor. So therefore the correct answer is option 4, that is X is copper, Y is nichrome and Z is semiconductor. Given a current carrying wire of non-uniform cross section, which of the following is constant throughout the length of wire? Drift speed, current and drift speed, current only, current, electric field and drift speed. Current is very cross section, current is every cross section is same irrespectively of area of cross section. So therefore the option is 3, that is current only is the correct answer. Next, 27, the graph between variation of resistance of a metal wire as a function of its diameter keeping other parameter like length and temperature constant is R is equal to A, so therefore R is equal to P by pi R square, so therefore the correct option is option 3. Next, 28th question. Two thin long parallel wires separated by a distance r from each other in vacuum carry a current of 1 ampere in opposite direction. Then they will attract each other with a force per unit length of, or rebel each other with a force per unit length, or rebel each other with force per unit length, or attract each other with force per unit length. So therefore F A by L is equal to mu not I comma I by I2 by T by R. So therefore the correct option is option 2. A solenoid is 1 meter long and 4 centimeter in a diameter. It has 5 layers of winding of 1000 tons each and carries a current of 7 ampere. So the magnetic field at the center of the solenoid is, so therefore L is equal to 1 meter, R is equal to 2 centimeter and N is equal to 5000 and T is equal to 7A. and sin theta is equal to 1. So B is equal to mu naught Ni by L into sin theta. So therefore B is equal to 4 pi into 10 to the power minus 7 into 5000 into 7 into 1 by 1. So therefore it is equal to 4.396 into 10 to the power minus 2t. So therefore it is equal to option, the option is option 2. In 30th question, two similar galvanometer are covered into an ammeter and a milliammeter. The shunt resistance of ammeter as compared to the shunt resistance of millimeter will be 0, more, less, equal. So therefore Is is equal to Ig into H plus S. So therefore I is equal to Ig into G by S plus 1. So therefore more S, less I. So therefore it is option 3, that is less. So let us continue the other questions in my upcoming video. So this is the first part. So if till here I think you have understood what will be your answers and how to solve these the questions. So if this video is helpful, please give a like and also share my video with your friends. So okay friends, I'll see you in my next video. Till then, take care, have a nice day, bye my dear friends.